Hello, everyone. My name is Roland, and I'm a board advisor to New Quantum. I'll be moderating this panel. One of the particular properties of this panel is I think we are the customer-facing team here, as far as either, as I'll ask the panelists to introduce themselves, they're either operating data centers, including exposing cloud-exposed quantum computers, or worked for vendors who are also very much in touch with enterprise customers. My biggest regret coming into the panel is, why did I not talk to Neil last night? Because looking at the temperatures in London when I left the US, I did have a pair of shorts in my luggage, but here I am looking like a finance guy, which I'm not. So let's just go in line and do a quick intro of what we do and which organization we're with, and then we'll get going.
Okay.
Andrés?
Well, thank you to the organizers for inviting me to be here. It's a pleasure. My name is Andrés Gómez, I think. I work for a supercomputing center in Spain that is in Santiago de Compostela, in the northwest of Spain. We are the second supercomputing center inside in Spain. And we are a national facility and a regional facility at the same time. My role as applications and project department manager is to manage a team of people working in several areas with our users. So for the reason we are detecting continuously the needs of our users, the requirements, and we are testing the new technologies for the future. That is one part that is important. In my case, I am leader also all the quantum technologies activities at CESGA, both quantum computing and quantum communications. We are not working yet in linking both, but it's something in the future. In the part of the quantum computing, we have bought a quantum computer in 2023, I think, that was operational since at the end of the year and has been working during more than 1 year without any problem. And we have been working with QC, that is the QBO that Owen presented this morning, in the integration between HPC and quantum computers and the quantum communications. And we are deploying a QDA link of 120 kilometers that I hope that will be available after the summer.
Thank you. Luca?
Good afternoon. I'm Luca Della Chiesa. I'm instead working for Cisco as a distinguished engineer in the optical architectural team in a business unit that is called Infrastructure and Security. Now, what we are doing and what I'm doing is actually, I have 20 plus. 20 plus is enough because saying close to 30 sound.
Ask your grandchildren if you want.
Okay, 20 plus year on classical networking, particularly on the optical and transport, but in general in what is classical networking. And I mean, probably all you knows that Cisco is, expert in networking, in all kind of networking. And why I'm here? Because I'm the one inside the view that is looking, okay, when quantum will be mature enough to make a product, especially the networking part of quantum will be mature enough to make, or interesting enough to start thinking a product. So that's, and thanks for inviting me.
Thank you for coming, Luca. Laura?
Hi, everyone. My name's Laura Martin, and I am from the National Quantum Computing Centre of the UK. We're the new kids on the block. I have quite a long job title. It's Quantum Computing as a Service Cloud Engineer. So what that means in real terms is that I am the person who builds, maintains, and administers access to all of the commercial cloud platforms that we have at the NQCC, which are intended to enable researchers, primarily academics at this stage in time, but in the future, small R&D companies are very much going to be our focus, small and medium enterprises, to access quantum compute. So that is done through our Spark capability, our Spark program. And within that, the Quantum Computing Access Program, QCAP. We love an acronym at UKRI, STFC, NQCC. So that's what I do. In the future, we have wider ambitions for how we're going to integrate what we have at the National Quantum Computing Center into the cloud. So that includes our internal R&D test beds, but also the SBRI program test beds that you can read all about on the NQCC's website. I cannot be trusted to remember all of them off the top of my head, because I think we have about 10 quantum computers of all different creeds and colors at the NQCC at the moment. So I'm happy to answer any and all questions about the NQCC and what we do there, and about the work that my wonderful colleagues and I do.
Cool.
Tom.
So, Tom Winstanley, I can't compete on acronyms, I don't think.
Please don't try.
And I'm not going to try. So I'm Chief Technology Officer for NTT Data here in the UK and Ireland. NTT Data is part of the NTT Group, which is the Japanese BT, just way cooler. We are materially invested in the R&D side of both quantum, but also very much photonics. And I've seen today there's been some really interesting talks by I would say fellows and colleagues Riken, where we are also working together on quantum and photonic activity to accelerate our space over there. But the other side of our business, one foot in the R&D side, one foot very much in the world of large-scale data centers. So we're Entity Data Inc. outside of Japan. Broadly, two parts of our business. We're a consulting and systems integration house. So we're interested in the applications of the technology, but we're also, as I say, the third largest co-location data center provider in the world outside China. That means we're operating centers here in the UK, across the whole of Europe, investing materially, also in APAC, in India, in the US, Latin America. And so I would say probably the most quantum ignorant of the people on the panel today, but have a real focus on how we can find the real world applications that also make it practical and sensible for us to bring it into our wider data center infrastructure.
Great. I will challenge you on the most quantum ignorant position on the panel, but we'll roll with it. So I thought we'd start a little bit, since we are the customer-facing members of the day-to-day. Start a little bit with the what, meaning what are you seeing as far as your users currently with what's available in terms of hardware that's exposed? What kind of profiles? Is it, computer scientists learning how to do small circuits and programs? Is it chemists, physicists, etc.? And if the answer is best informed by what kind of quantum computer or annealer or what have you is actually, that gives context that may be helpful. And for those who aren't in the cloud business, maybe how does your company, what's the angle of interest in quantum for the company that you're with? Does that make sense?
Sure. So I can speak a bit to that. So in terms of what we're seeing, everything really. There's with the caveat that the NQCC has only been open and fully operational for just about a year now. We've seen an incredible heterogeneity of projects coming through our Spark QCaaS program. So I've seen everything from modeling Bose-Einstein equations to figuring out what the best configuration for police cars to be in rural North Wales. There is an incredible range of things that people want to use this for. Most recently, at Harwell campus, where the NQCC is located, we had a conference where participants in the proof of concept round that we hosted and funded, and our quantum applications team helped with between about January and April this year. They presented things on as wide a range of subjects as quantum-enabled machine learning for liquid cancer biopsies, so looking for fragments of cancer DNA in people's blood samples, through to how can you best load an aircraft to optimize the center of gravity, because apparently over a transatlantic flight this can make as much of a difference as 4 tons of fuel use. So really wide range. If anyone wants to go and read about those proof of concepts, we've just published a really interesting booklet on that, so do go visit the NQCC's website. In terms of our academic stream, we've had about 15 distinct universities so far apply. And I think that is definitely going to continue to grow, especially because I am trying to plug the program as much as possible, because it frustrates me that I go to these events and people go, oh, NQCC. What do you guys do then? Because, like I say, we're pretty new. So please go and tell everyone that you know, whether they're in research or industry, this is what the NQCC does. Please apply to their Quantum Computing Access Program. At the moment, it is primarily open to academic groups and researchers. But like I said, there are these proof of concept rounds that focus on small and medium enterprises, R&D. We previously worked with Mind Foundry, a very interesting AI company. Applied Quantum Computing as well, another small sort of Oxford University spin-out company. So there's a huge range, and there's a clear appetite for it as well. And we're really enjoying working with the quantum hubs across the UK, as well as the QSL up in Edinburgh, to enable this. And this is all via QCaaS. So this is all being being given access through our commercial cloud platforms. So Azure, AWS, IBM, and also D-Wave as well.
I mean, I was going to say I can maybe look. I mean, I can probably build on that. I'm imagining also unsurprisingly quite similar. So we for a number of years have had a unit called NTT Data Mathematical Sciences, right? So that's a group focused in 3 centres across the world, and theirs is always their use cases have always been about optimization. The example of the police in Wales is an interesting one. It's a very similar project that was done in Tokyo for the emergency services. The aviation optimization, again in aviation, really is one that is actually active right now at the moment with our team in Tokyo. A bit closer to home, financial services for sure, kind of risk portfolio modeling type things where you're getting over effectively the if you get it right, it makes such a huge difference. It's commercially worthwhile to do. Therefore, people are interested in spending the money in a way that they might not in other areas. Let's put it that way. And the other one that's actually is quite fun from our team in Germany, and Raoul is here somewhere in the room, with BMW and the BMW Quantum Challenge, which was about the wonderful world of homologation, which I'd know until 2 years ago. I'm delighted to say I had never heard the term homologation. The process of certifying all of the constituent parts of a thing to be secure and standardized and appropriate for sale in different markets. It turns out that's actually more complicated than you might first think, and it actually lends itself really well to quantum optimization approaches.
Okay. In our case, we are a research national facility, so we have a very large number, well, large, not large for a supercomputing facility, but large for a quantum computer. We have around 70 people working with our system. Since today, we have another 18. Because today we have resolved the one open call that we have to attract other researchers from the national facilities for the national universities. But we have people working up all the layers of a quantum computer. The physicists working in quantum physics want to work with the qubits itself, because it's a quantum system, and they want to operate with the quantum system directly using pulses and trying to understand the Hamiltonian of the system, or trying to find properties of the full QPU. We have people working in the interfaces between the HPC system and the quantum system, because there we have to do a lot of work. In fact, we were working with OQC in order to improve the link between these two areas, but there are people working in intermediate representations and how to link the high-level programs to the low-level QPU. Even in one case, we have people working in network quantum intermediate representation, NetQuirk or something like that. I don't remember the name. If we go up, we have people working in algorithms, in general algorithms, in order to improve the current algorithms that we have in the markets. And the last level, of course, is the final user that only wants to submit something and have a solution. So the problem is for this kind of people, don't care about the technology. The only thing is the solution. So in all the layers, you can have very different examples from the universities to companies. In the universities, for example, we have people working in know more about the crosstalk between the qubits. That is one important issue. Or non-Markovian errors in the QPU that can evolve time to time. But in the other side, for example, we have several companies working with us. One of them, they are trying to understand the system because they know that the system is not big enough for the problem, but they want to be there with the algorithms for the future in order to have solutions for their own products. They are related with analysis of chemical systems. And when they have a big computer or big enough computer to be there. Or we are working with companies in order to develop solutions for distributed quantum computing. We have a platform to emulate distributed computing without quantum communication yet, but with several QPUs. And in this case, we have been working, for example, with Quoro, that is a British company that tested the system in our platform, or with another local company that is Bahia, that developed a solution for, in this case, distributed QDA, that is for solving combinatorial problems. So you can see that the number of cases is increases daily. Every day that I own the office, I have a new case on my desk asking if it's possible to run in our system.
So, as you suggested, Roland, I will address the question from a different perspective. So, because definitely a customer will not come to Cisco to ask to solve complex differential equation. But we are start to get question also from a quantum networking perspective. Obviously, most of the customer are coming scared about the quantum and asking for a solution. I mean, initially fascinated by QKD. I'm not a fan at all of QKD because the first question is, do you support QKD? The second question is, can you put QKD in the same fiber with classical channel? And obviously, that we can become, let's say, I will lose my hair to explain how complex that could be. But that's not the only kind of customer. There are also some customers that understand a bit more quantum. And start asking us, okay, tell me about quantum networking, what you are doing of quantum networking. Oh, by the way, can you deliver me a quantum networking to solve a CHSH game? Wow. I mean, yes, you can do it. I cannot deliver today quantum networking that is capable of doing that. But okay, let's chat about it. Or there are other kind of customers that instead are really thinking ahead in our direction, substantially saying, okay, I understand that quantum networking would become essential for making quantum computing useful. But can you do a quantum networking that I can buy from IBM, I can buy from Quantinuum, and put everything together? So, okay, these are the kind of questions that are coming today from smart customers that obviously may think to look very ahead, but not have completely clear the picture. I mean, I'm saying that just imagine that, I mean, I heard, I think, in one of the panels today, oh, this is so difficult, will never happen or will take so long. So Given the fact that I'm close to the 30 years of experience, let me share with these guys that not many of them has white beard. Sorry, Tom. And I saw so many technology burning in my experience, and I mean, one of them, for example, coherent. Coherent has so many parameters that when we saw the first time, we saw. I mean, I was one of the saying it will never be possible to make interoperable. Now we have standard, and you can buy pluggable from different vendors. Or the first coherent was probably a box that would not fit in one of these. Now we have into a pluggable, and you can buy from different vendor and interoperate. So, I mean, the question will come, and I'm sure that it will take 10 years, 20 years, but you will see interoperating and multiple technology put together. Just.
Right. And for anybody who hasn't spent 30 years doing telecom, like Luca and I, coherent refers to on-off keying on when you have DSPs and modulation schemes that are complicated. Maybe I would also drill a little bit if you guys can help us with in the quantum usage that's happening today, and maybe contrasting it a little bit with if you've done and been around HPC service offering prior to that. Because of the novelty of quantum usage and focusing on the users who come at it, I have an application, I'm a chemist, I'm a financial guy, and so on. How much is it in the end, how much hand-holding is involved? Meaning they come to you and you have to tell me about your problem. Well, I advise you to use D-Wave because it sounds like an easing and kneeling, or do they mostly come, hey, look, give me an hour on Wednesday between 11 and noon and get out of the way, I know what I'm going to do. On that spectrum, I'd love to hear a little bit about how much it's a consultative service, much more maybe than where HPC is, where maybe people would just self-serve and do what they want.
Well, even in the area of HPC, in our case, we think that we have to work together with the user in order to understand the problem, but also to develop the solution or to test the solution with them. Because they have the knowledge in the area. We have the knowledge in the quantum computing or in HPC, but we cannot know about everything in the world. Okay, so I have several projects with companies, for example, that is maybe is the best one, where my requirement to work with them is you must allocate people from your company to the project with a very amount of time in order to analyze together the problem, to find a solution together, and we can provide the knowledge about the using of the technology. For example, I have been working with a company during the last 8 years, developing machine learning solutions for manufacturing. And more or less now the team is 1/3 of the people from the company, 1/3 of the people from my center, and 1/3 from one university. Okay. And we have now more than one patent because we have been working together. They know very well the problem that they solve. And when we provide some solution, we find another problem that they want to solve, or they think, okay, maybe it's not good enough for the solution, for the problem that we have. I think that in the quantum is exactly the same. In the several projects that we have with companies at this moment, we have a strong collaboration with the technicians of the company, even with managers of the company. The only thing that they know is what is the problem that they want to solve. And it's something that is important to transfer the knowledge from the company to us and transfer the knowledge from us to them in order to make a final agreement about the possibilities of the quantum computing now and the possibilities of the quantum computing in the future. Okay. So,
Laura, any?
We certainly get an interesting range of expertise levels. I answer queries that range from you know, where do I find my API key, right up to what are the qubit coupling strengths between this qubit and this qubit. So you certainly get a range. The feel that I get is that the different cloud platforms tend to have their own software development kits. Qiskit does seem to be pretty dominant, and so a lot of people have experience with Qiskit, but people are coming and are very interested by different modalities. So they are increasingly upskilling and learning to sort of translate between them. And I think it leads interestingly to a piece of internal work that the NQCC has been doing, which is working on its own internal transpiler, which is called QUON. KWON, for once, a quantum acronym that doesn't have a Q in it. Yes, I know, it's controversial. So there is this interesting tension, I think, between the range of modalities that people want to see, and the range of modalities people want to use, and one language being quite dominant at the moment. But we are starting to see more expertise popping up. And we do see a range of sophistications of the projects as well in terms of applications. Sometimes they are quite early stages. We're really just exploring this for the first time. And sometimes there's been an awful lot of prep work that's been done before. And this is why we have our own internal academic review process that sort of assesses, are you ready? Do you need to do another 3 months of prep work? And we have said to some projects, I think you need to go back and do a little bit more prep and then come back to us for a future round. And that's been really productive for those particular projects. One thing that we are doing in terms of enablement for the UK ecosystem as a whole is we have our annual quantum hackathon. So I apologize, it's a little bit too late for applications. They closed back in June, but it's running in about 3 weeks' time up in Edinburgh. And that runs annually, and we circle around different universities in the UK. So we try and serve the whole of the UK region by region. So last year we were at Warwick, this year we're up in Scotland, and next year, who knows, we'll be. But that offers a really great opportunity for 2 to 3 days of intensive, everyone's together in the same room. You've got providers mentoring students who are mostly masters, DPhil, postdoctoral, some early career researchers as well. And we have use cases from industry. So bringing all of these things together really helps develop the skill set, but also it helps the industry providers to say, actually, we didn't know that quantum could work for this. So I think that's something that we're trying to do at the NQCC in order to increase the amount of expertise there is in the UK.
I mean, I'd build on that at this point of expertise, because that's hugely the issue. That's hugely the barrier at the moment. Certainly on the industrial side, obviously, where you've got academic teams as the primary clients, then it's a whole different ball game. But one of the things that why we're even in this space, frankly, is bringing together the two parts of our business that I talked about before. You've got data center operation, and you've got consulting and systems integration house. And so what we're typically finding for the kind of work that we're interested in supporting, where we can see the kind of the scaling, frankly, for those, it is bespoke projects, it is heavy upfront framing, shaping, conceptualizing, working out what the right approach is, even the right modality, before we even get into now let's book the space and the capacity. It's very still, for us at least, very bespoke. But we're in a different world to the HPC providers here. You've got this kind of the academic part as well, kind of key.
Right. So notice to the audience, I'm going to start asking for any questions. One question. That's it. And then we're on. All right, great. Well then.
There's drinks afterwards. You can ask all the questions.
And there's a lot of smiles, considering that you've been in this room for a long time. I'm impressed with the energy and passion.
Mine My next question was going to be about the sausage making of operating a cloud, data center. So if I've given you enough nausea from that warning, go ahead and pose your question, which is more interesting. No? Then I'll ask my question. So I was interested, well, no? Okay. The question I had was maybe educating people who haven't been in the business of providing cloud services and HPC services or data center access to customers. What it's like on the inside when you think of maybe, the figures of merit, like, downtime is a bad thing, you want utility level, particularly in quantum where there's frequent recalibration of the systems, so either planned outages or unplanned outages. I suppose some of you are dealing with some, quote, non-status quo things like, bringing GPUs now which need their own liquid cooling, which was not part of the original air cooling for, etc. So open-ended on the how and what it's like to live inside that, behind the curtain.
I can comment here as I skipped the previous one. So, okay, let me start in this way. Whenever we will start with working with hyperscaler, and I know that some of you are engaging hyperscaler, but I think you are engaging the one that understand quantum and that understand the complexity. I mean, when you will start engaging the operation part of hyperscaler, you will learn that fault tolerance has a completely different meaning. That means that for them, as they pay for something, that stuff should work ever. And it may fail, but it should continue working, meaning that you mentioned recalibration, it's your problem. So you're selling me something that should work.
I'm not paying for recalibration.
I'm not paying for recalibration. So that means that probably we should start thinking the architecture and also the control in a way that recalibration is something that is happening. I mean, even the network should be able to take a part of, a QPU out without affecting what is working or what is going on, so the work. But I think that is even worse, the failure. So today, hyperscaler built on most of the GPU, what is called the time checkpointing. So that means they stop everything, they dump every minute, 3 minutes, in order to get an image that if any of the GPU fail, they don't lose hour of work, but they restart. Now, when we talk about quantum error correction, let's start thinking that you will get the question, can error correction address also this? Yeah. Just to give you a warning, this is what you will get from these guys.
Yeah. Other aspects, facilities, or other, yeah?
Allow me, we are a small center. We are around 50 people, and we don't have a lot of people to take care of the management of the new equipments. So one thing that we request always is the warranty that the system will work during the next 1 year, 2 years, 3 years, without interruption, without intervention of people working on the system, if it's possible. In quantum computing at this moment, it's not possible. But we will need at least a guarantee that 99.99% of the time the system will be available per year, because we are allocating resources to people and they claim for the resources. If I said that you will have 100 hours of my QPU during the next 5 months, for example, as we today allocated to 19 people, in this case, if I don't have enough time for providing these services, I am in a hurry. So the stability of the system for us in our center is clearly a demand. Fortunately, We were running the system for more than 1 year without any interruption. That is really good. And this is the thing that we want to have in the next 3 years. Okay. And the second point is that the quantum computer or the computer with a quantum unit must be integrated in the facilities for monitoring and testing the system and the quality of the system. In the case of the quantum units, this is something that, in my impression, is not solved yet. We need to know exactly the quality of the qubits before submitting a job, during the execution of a job, because if we cannot measure this quality continuously, we cannot guarantee that the result is correct. And the users want a correct result. So for the reason, these are more or less the main requirements that we are pushing to our providers: stability, integration in our system, and monitoring and continuous monitoring.
I would have loved to finish, but time has been called on me. Thank you all on the panel. I've learned that we're more demanding of an academic supercomputing service than we are of airlines. So I think we need to rebel on airlines. Thank you so much. Join me in thanking our panel.